Okay, so here in this third equilibrium, we're going to take this complex ion. It's a cobalt 2+ ion, but the water kind of attracts to it. Don't worry about that. Really just think of it as the cobalt 2+. And this is pink. Okay, but when it's in this form, it's blue. So if I take some of this and then I add some HCl. Now if I'm going to add HCl to this, which part of my reaction is that going to change? Think about this. HCl. What's the only thing in here that it's going to change? Well, it's going to change this chloride. It doesn't matter, the H+ will be there, but I'm going to increase the chloride ion concentration. So as I do that, I take this and I take some of my pink cobalt 2 and I get my 3 milliliters in here. Okay, so there's my 3 milliliters or so. And then it says, pour 3 milliliters into a beaker, add concentrated hydrochloric acid. Now this is a very dangerous, strong chemical, but we're going to be careful with it. And I'm going to add this. And I'm going to have to add a decent amount. But I don't know if you can kind of see the color change taking place. Okay, ooh, I just caught a whiff of the HCl. Ooh, look at there, now it's kind of a purpley color. A little bit more. Now it turned into that blue. So I've shifted it completely to the right. Okay. Now the next part says to add some water to it. So when I add water to this, it actually makes it go back pink. Okay. If I add enough, it'll all turn into the pink color again. Now it's a diluted pink because I added so much more water, but it's going back pink. So if I look at this equilibrium, right here, when I add the HCl, obviously that's going to shift the reaction to the right and make it go blue. But when water's not, it's a liquid, so it's not in the equilibrium expression. Now we would think add water, it's going to push it that way, but water's a liquid. So here's something that you need to know, that when you dilute an aqueous solution like this, the reaction is going to shift to the side that has more moles of dissolved ions. Since there are 5 moles of dissolved ions over here and only 1 mole of dissolved ions here, diluting it with water actually forces it here. So it's not the water itself adding it. It's not because water's over here on the right, because it's a liquid. It's not in the equilibrium expression. It's the fact that when you dilute, the reactions shift to the side with more moles of dissolved ions. So it's going to shift left. Okay? Now, let's look at the last one. We're going to take some saturated ammonium chloride. Again, we're going to just do our 3 milliliters of it. I need a faster drip bottle. Okay, so there's about 3 milliliters. We're going to take some more of the concentrated HCl. Now, kind of watch it carefully as I put this into here. You can see it looks kind of like it's snowing. Okay? So a white solid is being formed. Now, if I take this, I'm supposed to have some boiling water, but I forgot to get the water going. In class, they put it into boiling water, but I'm going to put it over just the burner. I'm just going to heat it up a bit. Okay? So as I just heat this up just a little bit, Kind of stirring it as I'm heating it just by shaking it a little bit. This is on the outside. You can see that all of your solid redissolved, okay? Now, we'll talk about that in a second, but the last part of this says to take some sodium acetate, solid, pardon me, some ammonium chloride, solid, and I put that into a test tube, and then I just add some water to it. And we're basically just dissolving the ammonium chloride into the water. Okay, nothing fancy's happening, but if I feel the test tube is very cold. Test tube is very cold. So as a result, does that mean that the dissolving is endothermic or is it exothermic? Okay, hopefully you responded to yourself endothermic. Okay, so where would heat go then in our final equilibrium? If I'm looking at this equilibrium, if it's endothermic, where does heat go? Again, I hope you said it's going to go on the left side as a reactant. Heat's going to go here. So as I added in Cl minus hydrochloric acid, that increased the Cl minus concentration, which caused the equilibrium to shift away from that, and we made more solid. It looked like it was snowing. Okay? But because the reaction is endothermic, when I put it in the heat, that drove it back to the right and caused it to redissolve again at the higher temperature. So we use temperature to cause the change in the equilibrium. So these are your 4 equilibrium. You need to make sure you just kind of record observations. Okay, pause the video if you need to just kind of see. Go through all 4 pages of your data. Record all the observations and answer all the questions. Then there are the 4, I think there's 4 conclusion questions somewhere in the middle of the packet that is posted in Classroom. Okay, all of that's going to be due on Monday. If you have any questions about anything that you saw in this lab or that, as you're answering the questions, email me. I'll be glad to help you. All right. So hopefully you enjoyed this virtual lab. It's much more fun if you're here doing it, but this is the best we got. So let's have a great day and go Jags.